Now we'll talk about inverse functions. And the definition of inverse functions is the functions f and g are inverse functions if, whenever the pair AB, which is on the function y equals f of x, the pair BA satisfies the function y equals g of x. And I'll explain what that means with an example in a moment. But what we have to be careful of is to notice that a function will only have an inverse if it is one-to-one. So if we don't have a one-to-one function, then we cannot have an inverse of that function. So let's see if f of x equals x to the third minus 2 has an inverse. And you can graph that on your calculator if you would like. I'm going to graph it by doing an f of x equals x to the third minus 2t table. And so on that graph, I'm going to put in a -2, a -1, a 0, a 1, and a 2 for x, and we'll see what y equals. -2 to the third power is -2 times -2 times -2. That's -8 minus 2 is -10. -1 to the third power is -1 minus 2 is -3. 0 to the third minus 2 is -2. 1 to the third minus 2 is 1 minus 2, -1. And 2 to the third minus 2 is 8 minus 2, which is 6. Now these values you could get by graphing f of x equals x to the third minus 2 and shifting and then using your trace button. So do trace -2, trace -1, trace 0, and so on. So I'm going to plot those points on my graph, and then I'm going to double check and make sure that that is a one-to-one function. Okay, so -2, -10 will be off my graph, so I won't plot that one. I'll plot -1, -3. -2, -10 would be down here off the graph. Then I'll plot 0, -2, 1, -1, and 2, 6. And I'll graph it. You know that that's a graph of y equals x to the third shifted down 2 units. So does that have an inverse? Yes, it does, because it passes the vertical line test and it passes the horizontal line test. So if it has an inverse, we will be able to graph it. And so now I'm going to graph of the inverse. We're going to do the graph of the inverse. And the inverse, we don't know the equation yet, but the inverse is always written as an f with a little -1. Looks like an exponent, but that is not an exponent, and then you're of x. So when you see this notation, you know that you are talking about the inverse of f of x. Now the inverse is very easy to graph if you have the original function, because this says when the pair AB is on the regular function, BA is on the inverse. So all I have to do is switch my x and y values around to get my points on my inverse. So -10, -2, -3, -1, -2, 0, -1, 1, and 6, 2. Those are the points that I'm going to plot on my graph. So -10, -2 would be about right there. -3, -1, -2, 0, -1, 1, and 6, 2. And then we'll just kind of connect those. like that. So our function that we started with is the green graph, and our inverse is the pink graph. And what I want you to recognize is that these two functions that we have graphed are reflections in the line y equals x. So if I were to draw the line y equals x, I would be graphing the points -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. So if I graph those points, and I'm just going to make a little dashed line because that's not actually part of our graph. That is called the line of reflection. In other words, these graphs will reflect across the line y equals x if you look at each point, and that's because the x and the y values are reversed. Now, to find the equation of the inverse, there are some steps that we need to go through, and so I'm going to talk about those steps. To find the equation of the inverse of f of x, you do a few things, and if you'll do these steps in order, you'll get the inverse every time. Step 1, I'm going to write down my original function. Step 2, I replace f of x in my original function with y. Remember, those mean the same thing. So in other words, I'm just going to write this in terms of x and y so that we can do something with that in a minute. So all I've done in this step is I have replaced f of x with y. Now the third step, I'm going to take this equation here, and everywhere there's a y, I'm going to put an x, and everywhere there's an x, I'm going to put a y. So what I did was I just switched my x and y's. And then what we're going to do in the fourth step is we're going to rearrange this equation so that we have solved for y. So in order to do that, I'm going to add 2 to both sides. So x plus 2 equals y to the third. And to solve for y, I need to get y by itself, so I will take the cube root of y and the cube root of x plus 2. So y equals the cube root of x plus 2. Now our fifth step, which I'll go over here, is I'm just going to rewrite this in terms of function notation again. So my y now becomes f inverse of x because we found the inverse, and that equals the cube root of x plus 2. So here is our equation of our inverse, and all I did was replaced y with the notation for inverse of a function. And we'll practice on some more of those in a moment. Now let's see what this equation says. This says we're going to take the cube root of x and move it 2 to the left. And if you'll notice, and you'll remember what the cube root of x function looks like, this is the cube root of x moved 2 to the left.